Hi folks, we're going to take a look at 10a from page 434. So here they give us the equation of a line and they give us the vector equation of this line, and they want us to find another line which is perpendicular to the given one and passes through the point 2, 0. Okay, so they've given us half of the information we need. So we have our point on the line, which is 2, 0. So the only other thing we have to find is a direction vector. Okay, so let's see how we can do that. So let's say I just draw myself little diagram here. Okay, so let's say here's the line. Okay, and I know that the vector 3, 5 is a direction vector for this line. Okay, so one thing I realize is that any line that's perpendicular to the given line is also going to be perpendicular to the vector 3, 5. So if I wanted to find a direction vector for this perpendicular line, I could use the property that the dot product of two perpendicular vectors is 0. So I could take 3, 5, okay, dot it with the direction vector for the line that I'm looking for, which is perpendicular, and I know that that would have to be equal to 0. Okay, and I could just solve, just distribute this out, and I'd have an equation. So I'd have 3a plus 5b is equal to 0, and I could just find a direction vector using this here. So let's say I pick, let's say I pick a equals 1. So I have 3 plus 5b is equal to 0, so b is equal to negative 3 over 5. Okay. So there's an equation for my line. R is equal to, well, I know it passes through 2, 0. Okay, plus, I'm not going to use s since that was used in the other equation, so plus t times, well, remember we chose a to be 1, b to be equal to negative 3 over 5, and there we go. There's an equation that we have. So this is one possible solution, is to use this idea that the dot product of two perpendicular vectors is 0. Okay. I am going to show you an alternative here because it's something that might end up being useful in other contexts. Okay, and it's the fact that we are working with a 2D line, meaning we can make a relationship to slope. So let's say we take this direction vector, okay, and we place it at the origin. Okay, so this is the vector 3, 5. So that means we've got 3 and we've got 5 there, and so or 5 over here, I suppose. Okay, and what we can do is we can use the vector to find the slope of this line. Okay, because we see that the rise is just going to be 5 over a run of 3. So the slope of our line is just 5 over 3. Okay, so how do I create a line that's perpendicular to a given line? Well, we know that the perpendicular slope is just going to be the negative reciprocal, so negative 3 over 5. Okay. Now, remember, this represents, I'm starting from the origin, so I can think of this representing my delta y over delta x. Okay, so it could either be negative 3 over 5 or 3 over negative 5. Okay, so let's say I pick my x to be 5 and my y to be negative 3. So what does that give me? It would give me this perpendicular vector here. Okay, where this would be, again, x equals 5, I guess it would be a little further there, x equals 5, and y is equal to negative 3. Okay, this vector here is going to be perpendicular to the direction vector. Okay, so now I can use this vector as my direction vector to the perpendicular line, and I've got r is equal to, again, 2, 0 plus t times, well, 5, negative 3, t and r. Okay, and the question is, do these represent the same line? Let's just check that. Well, they both share the same point, and let's take a look at these direction vectors. As long as these direction vectors are parallel, then we're good. And if you notice here, if I take the vector 1, negative 3 over 5, and I multiply it by 5, what do I get? 5, negative 3. So this proves that these two lines are equivalent. Okay, now what I want you to think about is, can we come up with a general statement about a direction vector for a line that's perpendicular to a given one? Okay, I think if you think about it, you can see a relationship between these two vectors. Okay, so just to recap here, we're given a line. We needed to find a perpendicular line. We were already given a point. Okay, so a couple of ways to determine the direction vector of the perpendicular line was to use the dot product. Okay, we know the dot product of two perpendicular vectors is 0. Or to make the connection between the direction vector of the line and the slope of the line, and then use what we know about perpendicular slopes. Okay, that's it for this one.